I'm going to talk to you about complexity of complexity in software, so complexity twice. After the talk, Stanislas is going to talk about simplicity in software, so it's going to be fun to make the cross about my talk about complexity and his talk about simplicity. We'll see how it goes. So, before I talk about complexity in software and how we manage it, let's first talk about how it gets in software. So what makes complexity? And the thing that makes complexity, you have it in every company you work with. I would say you have him in every company you work with. Let's call him Jeff. That's him. And his manager love him because he makes stuff work. And his colleagues love him because when you have something that is a bit more difficult, a bit more out of the ordinary, and you go to ask him a question, usually we'll have a good answer for you. We will make something work, make something nice, something that you can immediately put in production, and that solves your issue. So really, Jeff is a really, really good colleague. And his main quality is that he's clever, right? He can make stuff work. And that is the start of the problems. Or at least that's the start of the complexity. Let me give you a small example of what I mean. Do you know what that is? Can anybody shout what that is? Nobody. Good. So it's part of the source code of Odoo. It's a regular expression. What does it do? Who cares? Nobody knows. You can't even read that. It's part of the JavaScript minification process. A very, very clever idea, right? We needed to strip out the comments of the JavaScript, so we found a really good regular expression that does that. It was a very clever solution, reasonably efficient, but you probably can see a few issues with that. So, working solution, clever. If it works, it can't be bad, right? But this is the start of what I call the complexity about complexity. Before we dig too far, I would like to tell you about the two different kinds of complexity. This is coming from a book written by Brooks, and he says that the two different complexities are what are called essential complexity, so the complexity of the problem that you're trying to solve. And we say usually, if you have a very complex problem, the solution can't be simpler than the problem, obviously. This should be the main focus of our work as developer, solving essential complexity. And there is another kind of complexity. It comes from, it doesn't matter which problem, a hard problem, a simple problem, it doesn't matter. And it's the solution to that problem that is more complicated or more complex than the problem itself. And in my introduction to this talk, I said, okay, how you manage the beast? This is the beast, the complexity. We can also say that the complexity, which is accidental complexity, is the one that is created by engineers to solve other problems, and it should be usually solved by engineers to solve problems. So you have a part of your software. It doesn't matter how big or small it is. It's been made by Jeff or another Jeff. It doesn't matter which one it is. And it starts like this on the first day. You're very happy, your customer's happy, your manager's happy, but this is what you get after 2 years. It started like a good idea, right? A regular expression to strip comments of JavaScript. Pretty good, pretty simple. But after a few modifications, it becomes this huge beast, unmanageable, nobody understands what it does, nobody can modify it, or maybe just one guy can modify it, and it's pretty bad for your software. So what happened? What happened to your small, well, I'm going to say small with air quotes, regular expression, or your small system that was clever? It evolved, and software always evolves. This is the nature of our job, the nature of software, or the nature of the world. Whatever we do, it can't be melted in stone. It needs to evolve. There's many good reasons why it can evolve. Of course, a scope creep, so you design something to strip the comments for JavaScript. And then at some point, you also want to support TypeScript. That's a good scope evolution. If you don't mind, I'll get a little bit of water. Another thing that can make your software evolve, and it's also a really good reason, is security requirements. So you make something, you make it available, and then people start using it, which is good. But because it's now exposed, it needs to be secure or more secure than what you expected. And so you need to change the way it's done. Scaling is also a very good way to make software changes. So I work for Odoo, and I develop the spreadsheet application inside Odoo. And the initial version was designed to support per sheet 50,000 cells inside the browser. It's big, 50,000 cells. Each of them can contain a formula as complex as you want, and so on and so on. And we thought, well, 50,000 cells, it's way more than anybody will ever need. And obviously, the first thing that our consultants started to do was making sheets with 200,000 cells. And so our initial solution needed to scale more. Another good reason why your software might evolve is technologies. And this is a very broad term to say whatever you developed it in or for might evolve for legal reasons, for obvious reasons of security. If you say, okay, it was Python 2, we need to move to Python 3 because it's not supported anymore, you might need to change your technologies. And there's a lot of reasons why your software might evolve, or will evolve, I would say. And I'm going to say software, and I'm going to use those different complexities all in one group and treat them exactly the same way. So it's a class, a method, a program, or an entire infrastructure, all the same for me. Of course, 5 years and 10 developers later, your little regex is now absolutely unmanageable, and well, you are in a situation where you need to deal with the complexity of something that is complex at the start, which is evolved. And what do you do now with your beasts? How do you treat it to teach it new tricks? Remember, you can't say it will not change. So whatever you do, you know it will change. And if you say it will not change, you're just lying to yourself or lying to everybody else. It's a constant. So a bit like Alcoholics Anonymous, the first thing you do when you have a beast, you have to admit that there's a beast in your software. So that means you have to know where the pain points are in development. If you need to develop a feature or extend a feature, and you know your developers don't want to work on it, or you know that if they work on it, it's going to take 10 times more time than on any other feature in your software. Or there's only one guy that knows about it, because it's the one that did it, remember? The one that did this. And he's the only one that knows how it was done, even though it's now this or even this. You know it's a beast, a pain problem in your software, right? So admit that there's an issue. It's how it starts to solve the issue. The second part is probably the most difficult part and the most important. That is, it doesn't matter the size of the issue that you have identified. So it might be a subsystem, a class, a function. It might be your entire infrastructure. You have to explore the problem entirely and understand what it means functionally and technically, why you ended up there. Sometimes there's, when you started development, there are time constraints, and you will just do anything for it to work, and it's a good enough reason to do it. But it's not a good enough reason to keep it, and it's important to know. Sometimes the problem started very small and gradually expanded in scope. Like I said, the scope creep is real, and so you need to understand how it went, how it started, and why things are the way they are right now. Exploring the problem likely means talking to the person developing it, talking to the person specifying it, and talking to people in general about the problem and how other people are solving it. And you will see that talking to people is part of the solution in general. So once you have explored the problem entirely, you understand the problem. You understand what you need to do, and you know that what you have currently, your beast, is not exactly what you need to have. Once you have that, it's time to take action. And I will specify 2 actions that go together that we do to manage our own complexity. The first thing that you might want to do, and I would really love to give you a really cool recipe or cookbook to tell you, okay, you have to do first this and this and this, and whatever problem you had, it will be solved. It will be either simpler or you will reduce your cost later and so on, but I can't because it's every time very specific. So you know you have identified your pain points, you have done the work, you know what you want to do. I would say the first thing that you need to do is seek either to generalize or to specialize. Generalizing means you have a kind of problem, and maybe this kind of problem is also the same somewhere else in your application. You find similarities, and putting those similarities together might simplify the entire process. For example, this is something we did a few years ago in Odoo about the coupon system. So Odoo has a sales system, and there were coupon system and fidelity systems in different places. And of course, now I can tell you there were multiple different systems in different places because we did the analysis, we found all those different places, and it's very easy to say, well, if you had the same things or similar things in different systems, why didn't you put it together? But this is the work that we have to do, identify all those different pieces and put them together. So those different coupon systems were put together in one system that was slightly more complex than all those different those different little systems, but the overall complexity was reduced by a lot because we did duplicate a lot of processes, and also that means that when we needed to add new development on this subsystem, it was done once, and every piece of Odoo could benefit from it. So this is generalization, and the other one is specialization, and this is the opposite. So you have some piece of complex software, and after careful analysis, you find that the majority is simple, and there is one exception or a few exceptions. It might help to take those exceptions out, remake the system very simple, and make a very special edge case for those exceptions. Once again, I'd like to give you a cookbook, like in this case, do this, but it doesn't work that way. And how can anybody do that? Well, I would say talk about those problems. Discuss about your systems with other developers, with your friends, with anybody else, and they will tell you something like, oh, but your problem, it looks like this other problem that we already solved in this way. Or, oh, this problem looks like a biology problem. This is how it does in biology. Oh, this is like a logistics problem or mathematical problem. It can be solved in different ways. And this is really how we do in Odoo to find our pain points and solve them. In my team, in Spreadsheet, we do that almost every week. Spreadsheet is a very complex application. Everything is tightly interconnected, and every time we add something new, my goal is to not interconnect it more. So every time we add something new, we need to think about where are we in the overall architecture, and does it put into question any piece of the architecture? Should we extract out a piece that is now needs to be specialized, or is it common to something else that needs to be generalized? Those concepts, once you have found it, and once again, I don't have a recipe to find it, but talk to people, it's going to help. Talk about your problems and find similarities with what you know is going to help. It's very important to give them a name. Might be stupid to say, but when you talk about something with people, if you don't have a name to talk about it, it's very hard to have a meaningful discussion, especially if it's spread over weeks or months. So identify a new concept and give them a name, and then you can really talk about them. If you have new concepts, of course, it goes through software engineering practice like anything. Give it well-defined responsibility, cage them in a subsystem or a class or a function or whatever piece of the system you want to call, and don't let them escape. So don't leak abstractions is the known word, but because we talk about beasts, we don't let them escape. Something else that you might do is don't get attached. And I know it's weird, because if you have something that works, maybe it's in your system for 10 years, and it doesn't fit your need anymore, probably, maybe, redesigning is not the good solution. Throwing it away is a good solution. And when you do that, you need to cut deep. It was nice to know you, nice solution, but now it's time for a brand new one. Hopefully, with the knowledge of the system that you have after done once, you can do second time better. So make a new and friendlier one is the way I phrase it. And then same software engineering practice, isolate it, define it properly, give it a name, and then don't let it escape. In Odoo, we do that very often. We call it something apocalypse. There was accounting apocalypse, there was a lot of them, where we take a system, we change fundamentally something about it because it doesn't suit our need, because we identify it's a pain point, because development is too slow, or because we want. And then it's like throwing the system away, rebuilding on top of it with those new constraints, and hopefully it's going to be better. And well, remember, it's going to evolve, so we try to control the evolution. And this is basically my point about this talk. How do you control the beast? Well, you can't. It's going to evolve, but when it evolves, it's good to take a step back and really think about what you're doing. Thank you.